All right, so we're back again with the fifth video. And if you can turn to page 13 of your packet, we're going to get started. Okay, so number 30, I don't think this question is that bad. I'd like you to try it on your own. And then when you're done, you can hit play and check how you did. All right, so here, I'm just going to read it. It says, Elena has decided to run the Buffalo Half Marathon in May. She researched training plans on the internet and is looking at two possible plans, Jillian's 12-week plan and Joshua's 14-week plan. So we could see Jillian's plan is this with the dots, and Joshua's plan is this one with the X's. Okay, the number of miles run per week for each plan is plotted below. Okay, so we see that. We have weeks and we have miles. All right, so the first part, which one of the plans follows an arithmetic pattern? And explain how you know. Well, we know that an arithmetic pattern increases by a constant to get from one term to the next. So it looks like Jillian's plan here would be arithmetic because it's going up by the same amount each week. All right, so here we go. I just wrote that out. Jillian's plan, because it is linear, it increases by a constant of 1 mile per week. Alrighty, so the next part says to write a recursive definition. So basically write a recursive formula to represent the number of miles run each week for the duration of the plan you chose. So Jillian's plan is the one we chose. So we have to write a recursive formula for this. Okay, now we said it's arithmetic. All right, so here's our format for a recursive formula of an arithmetic sequence. So we just have to say a sub 1 equals the first term. So let's do that. So a sub 1 equals, and we can see on the first week right here, okay, week 1, she's going to be running 10 miles. So a sub 1 equals 10. Okay, and then we're going to say on the nth week, that's going to be equal to the previous term plus the common difference. So on the nth week, that's going to be equal to the previous term plus, well, the common difference, I mean, if you look here, right, she's going from week 1 to week 2, she's going from 10 to 11 miles. Then from week 2 to week 3, she's going from 11 to 12 miles. Basically what she's doing is she's increasing the number of miles she's running by 1 mile per week. So the common difference here would be 1. And that would be our recursive formula. Okay, and then this last part, Jillian's plan has an alternative if Elena wanted to train instead for a full 26-mile marathon. Week 1 would start at 13 miles, so that would be a sub 1, and follow the same pattern for the half marathon, but it would continue for 14 weeks. Write an explicit formula, let me just highlight that because that's important, in simplest form to represent the number of miles run each week for the full marathon training plan. I also want to, I'm going to underline this in simplest form. We're going to get to that in a little bit. Okay, now first, the explicit formula. Okay, so here's our explicit formula for an arithmetic sequence. So we're just going to plug in the information. So we know we want to leave it in terms of n. So this is going to stay as a sub n, and this is going to stay as n minus 1. We just have to plug in a number for a sub 1 as well as a number for d. Okay, so we're going to have, let's see, a sub n equals. Now, in place of a sub 1, this time they're saying week 1 would start at 13 miles. So our a sub 1 is going to be 13. And then we're going to have plus n minus 1. And then in place of d, it does say it would follow the same pattern that it was for the half marathon, you know, in the diagram above. So really, it's just going to increase by 1 mile per week. So we're going to put in place of d, we're going to put a 1. Now, unfortunately, if you leave your answer like this, you're not going to receive full credit because it says in simplest form. What that means is they want you to distribute the 1 and then combine your like terms, right? So, I mean, that's easy enough. So we have a sub n equals, let's bring down the 13, and we'll bring down the plus sign, and then 1 times n is n, and 1 times negative 1 is negative 1. All right, so that was a pretty bad a. So a sub n equals, and let's just combine our like terms. I'm going to bring down the variable first. That's up to you. And then 13 minus 1 is 12. So there we go. Okay, on to the next page, number 31. Now, this question, I want you, again, to hit stop, try it on your own. This one I think is much harder than the last one you did, but see what you can do with it, okay? A lot of you guys will be able to get the right answer. And then, same thing, hit play. You could, listen to my explanation and see how you did. Okay, so Simon lost his library card and has an overdue library book. When the book was 5 days late, he owed $2.25 to replace his library card and pay the fine for his overdue book. Okay, so I'm just writing this here to organize it. So for the library card plus 5 days of the book being overdue, it came to $2.25. Okay, when the book was 21 days late, he owed $6.25 to replace his library card and pay the fine for the overdue book. Okay, so what we could see is this fee included the fee for the library card plus an overdue charge. This fee contained that same exact fee, right? The library card costs the same whether it's 1 day late or 10 days late, plus the charge for the overdue books. So basically the only difference between the left-hand side of these equations is the difference in the number of days that has passed. So maybe what we could do is find the difference in the fee and divide that by the difference in the days, and that'll tell us how much it was per day for the overdue book. Okay, so let me just show what I mean. So we're going to take $6.25 and we're going to subtract $2.25 from that. So that means there was a $4 difference between the 5th day and the 21st day. Now, the only thing that went in, the only difference here was he was paying for an additional, if you subtract these, 16 days of the book being overdue. Okay, so if you do 21 minus 5, 16 days have passed. And when 16 days have passed, he owed an additional $4. So if you wanted to figure out how much it was per day for the overdue book, just take the $4 and divide that by the 16 days that have passed, and that means that it was 25 cents per day for the overdue book. Okay, so let's think about this. On the 5th day, he owed $2.25. So if we do 5 days times 25 cents per day for the overdue book, so let's just do that. So it's 25 cents per day times the 5 days that have passed. That only adds up to $1.25 in late fees for the book. So what that means is, see, since he had to pay $2.25 instead of $1.25, the library card itself must have been $1 to replace it. Okay, so let me just kind of go over that again. All right, so basically, let me put, this is money, let me just put the dollar sign there. So basically it was 25 cents per day for the overdue book. So every day that book is overdue, they're charging 25 cents per day. And then in addition, they charged $1 to replace the library card that he lost. Okay, so if you want to see if this makes sense, just figure it out, okay? 25 cents per day times 5 days is $1.25. If we add on the $1 for the library card, that is $2.25. Okay, 25 cents per day times 21 days. 25 cents times 21 is $5.25. If you add on the $1 for the, to replace the library card, that does equal $6.25. So that actually all checks out so far. All right, so now let me just slide this down a little so we can see what it's asking. So it says that suppose the total amount Simon owes when the book is n days late can be determined by an arithmetic sequence. Determine a formula for a sub n, the nth term of this sequence. Okay, now they don't say whether you have to do the explicit formula or the recursive formula, but I see there's some words down here, and if we're going to have to use that formula, honestly, I'd rather do the explicit formula because for the recursive, you would have to find every single term until you get to the term that, you need to use. So I'm going to do the explicit formula. All right, so the explicit formula. All right, so basically we have to decide, is this, we don't have to decide. They're telling us it's arithmetic. And the reason it's arithmetic is because it's going up by 25 cents per day. Okay, so our explicit formula for arithmetic looks like this. All right, so we want to leave it in terms of n. So we could say a sub n equals. All right, now the first term, even though it's 25 cents per day, he lost his library card, so he has to pay for that as well. So it's $1 for the library card plus 25 cents for the late book. So on the first day, he will owe $1.25. And then plus n minus 1. And then our common difference here is 25 cents per day. So we're going to multiply that by 0.25. And that would be our formula. If you prefer to take that formula and distribute the 0.25 in and, write it in simplest form, you can. Or you could leave it like that. All right, so now the next part, let me just slide this up. So it says, use the formula to determine the amount of money in dollars Simon needs to pay when the book is 60 days late. Okay, so this is why we use the explicit formula. If we had made a recursive formula to find the 60th term, we would have to know the 59th term, which would mean we would have to know the 58th term, and so on and so on and so on, all the way back to the first term. That would take forever. So instead, let's use this formula, all right? So a sub, now don't leave this as an n, right? What are we replacing with the n with? The n is the number of the term that we're on. Well, if we want to figure what he owes after 60 days, we're looking for the 60th term. So we're finding a sub 60. Okay, so now that's going to be equal to, now I'm just going to rewrite this entire right-hand side of the equation. But since I replaced this n with a 60, I'm going to replace this n with a 60. So it'll be 1.25 plus 60 minus 1 times 25 cents. Okay, so a sub 60 is equal to, and you could literally just plug this all in your calculator, and when you do, you get 16. Now, because it's money, and we always want to include our units, I'm going to write it like this, $16. Okay, if you didn't put the dollar symbol in front of it, remember, it doesn't go behind it, it goes in front of it, then you could write out the word dollars instead. So, yeah, that's a lot of money for an overdue book, but I guess it was really overdue. Okay, so number 32. This one's kind of tricky, so we're going to read this one together. All right. In 2010, the population of New York State was approximately 19,378,000, with an annual growth rate of 1.5%. Assuming the growth rate is maintained for a large number of years, which equation can be used to predict the population of New York State T years after 2010? All right, so this word after is like really important here. Since we're talking about after 2010, well, 1 year after 2010 would see how they're using P instead of using A sub n and A sub 1, they're using P. 1 year after 2010 would be P sub 1. So since this is the population in 2010, this would be the initial population. They're just using a P for population. This would be P sub 0. This is the initial population, okay? P sub 1, I'll just do it off to the side here. P sub 1 would be equal to the population in 2010 times 1 plus the growth rate. And the growth rate, since it's 1.5%, remember we would have to move the decimal place back twice. So here, your growth rate, if you move this decimal place back twice, it would be 0.015. So, coming back to this, P sub 1 would be equal to the population in 2010 times 1 plus 0.015. So whatever that's equal to, I don't really know what that's equal to. I would have to plug that in the calculator. But anyway, initial population, P sub 0, and after 2010. So P sub 1 would be 1 year later, so that would be 2011. P sub 2 would be 2 years later, so that would be 2012. Okay, so let's look at the answer choices. Now, they don't specify whether it should be recursive or explicit, so they can write this in either form. Now, just looking at these answer choices, I know choice 1 I can automatically cancel off because this says 1.5. We know this is equal to 1.015. So choice 1, that doesn't really make sense. So we're going to cross that one off. Now, choice 2 says that P sub 0 is equal to this, which is right. And then it says to find, instead of using P sub n, they're using P sub t. They're saying to find, the population of any year. And the reason they're using t is because they're saying years is t. You would multiply the term before it by 1.015, which is what this says, right? If we combine this, isn't this 1.015? Here, let me write that like that. Oop. 1.015. Okay, but we're not going to then add that to the initial population. Okay, that's not how it's growing. I mean, if you just multiplied the term before it by this, that would be okay, but not if you add the initial population onto it. So that would be way too big. Okay, so now let's go to choice 3. Choice 3 says, so this is the explicit formula. Okay, so I wrote the general formula of the explicit formula up here, except instead of a sub n, and instead of using an n here and an a sub 1, I just use the variables they use. I use p's instead of a's and t's instead of n's. So p sub t equals p sub 1 times r to the t minus 1 power. Now the t minus 1 matches up. The r, right, this is, our r we said, even though this is really sloppy, but our r is this right here. Okay, that's what we're multiplying by to get from one term to the next. But the reason why this is not the answer is because isn't this the value of p sub 0? Within the explicit formula, we need to put p sub 1 there. So if they had whatever 19,378,000 times 1.015 is equal to here, that would be correct. But because they put p sub 0 here, this is not going to be our answer. So let's hope choice 4 is the answer. So choice 4 says P sub 0, the initial population, is this number, which is good. And then it says to find the t, whatever term you want, you're going to take the previous term and multiply it by 1.015. Okay, so that is true. Choice 4 is the answer. Okay, so why don't you guys try out this one on your own? Hit pause, see what you get, and then we'll talk about it. Okay, so I just want to point out, when you read this question, they, again, just like the last one, we're talking about years after 2013. Okay, so what that means then, since there were, I'm just going to underline this, currently 2,800 breeding pairs, they're using F, so I'm going to stick with F. F sub 0, the initial amount of breeding pairs was 2,800. Okay, now, since they're growing at a rate of 2.4%, we know that to find F sub 1, we would take the 2,800, right? You'd have to take the previous term and multiply it by 1 plus the rate. Well, if the rate is 2.4%, if we move the decimal place back twice, wouldn't that be 0.024? So here, 1 plus 0.024 would be 1.024. Okay, so F sub 1 would be equal to, let's see, we have to approximate that, 2,867. Okay, so any answer choice that uses an F sub 1 that doesn't say this can't be the answer. So if we look at choice 1, they're saying the first year after 2013 is 2,800. I don't think so. That is the population of breeding pairs in 2013. Okay, same thing here. So choice 1 and 2 are not options. Okay, so now let's look at the difference between these. Now, it looks like they're following, since we're multiplying by 1.024 to get from one term to the next, we'd be using the explicit formula for a geometric sequence. Okay, so instead of using a sub n and a sub 1, I just used f because that's what they were using here. All right, so now, let's see. So f sub n, let me just plug in the numbers here. So f sub n would be equal to f sub 1, which is this, times r, which is 1.024, to the n minus 1 power. Okay, so this is the explicit formula. Now, if you look at these two answer choices, this doesn't match up with either one of those. So what are we going to do? Well, if you think about it logically, here, in choice 4, right, everything matches up. The exponent, what's in the parentheses, everything other than this number. So choice 4 can't be right. If everything else matches up exactly, other than the number in front, then there's no way they can be equivalent. So choice 4 is out. But let's just talk about why choice 3 is the answer. Okay, you can think about this one of two ways. You can either figure out, if choice 3 is equivalent to this by substituting in a number for n here and substituting in a number for n here and seeing if they equal each other. Okay, so I actually did that. I took choice 3 and I just replaced this n with a 2. And then I took this and replaced the n with a 2. Now, if you notice, they don't match up exactly. They're pretty close. But the reason why they don't match up exactly is because didn't I round this number originally? When you multiply 2800 by 1.024, it actually gives you 2867.2. So if I had plugged in here 2867.2 times this to this power, I would have gotten this exact same thing. Here, let me show you. Okay, so you can see when I plugged in the exact value of what this should have been equal to, see how this and this match up? So choice 3 matches up with our equation here. So choice 3 is the answer. Now let me just quickly explain why that's the answer. And let me just get all this out of here just to make some room. Here's what goes on, ready? See how this exponent is being raised to the n minus 1 power? And see how this exponent's being raised to the n power? Well, if I want to get rid of the minus 1, okay, if I want to if I want to add 1 to this exponent, what I have to do to compensate for that, since this number is on the same side of the equation as this exponent, if I decide that I want to add 1 to this exponent, if I want to progress a term, right, and add 1, then what's going to happen is I would have to go back a term here to compensate for progressing a term up here. So if I went back one term, think about it, this was the first term. If I go back one term, wouldn't that bring me back to the initial term of 2800? And then what would happen up here is the positive 1 and the negative 1 would cancel off. So it would leave me with exactly what it says in choice 3. Now, if that's too tricky to understand, you don't have to worry about it. It's multiple choice. Just plug in a number for n and plug in the same number for n into this original equation we had and just look at which one matches up. All right, so this is the last question we're going to do today. This one, I'd like you to read it, see if you could pick out which answer choice matches, and then, you can listen to how I went about doing it and see if we got the same answer. Okay, so this one here says that the day their daughter was born, they deposited $1,000 into an account that pays 1.8% interest compounded annually. Okay, so basically the day their daughter was born, well, that would actually represent A sub 0. A sub 1 would represent like her first birthday, right? How much is in the account after 1 year has passed. So, okay, so that's what we have so far. Now, it says that it pays 1.8% compounded annually. Okay, so this is the annual, which means yearly interest. Okay, so it's going to collect 1.8% interest compounded once a year. Okay, so what I did was, since it's paying 1.8% compounded annually, within our parentheses, annually just means once a year again, so within the parentheses it's just going to be 1 plus the rate. So if you take this decimal and move it back twice, it's 0.018. So 1 plus 0.018 would just be 1.018. So it's going to take the previous amount that was in there and multiply it by the rate that it's growing. Now, as we keep reading, it says beginning with her first birthday, they deposit an additional $750 into the account on each of her birthdays. So this interest is going to be, multiplied. Basically, the money that's in there is going to collect that interest. But then in addition to that, they're adding on another $750. Okay, so this same process is going to continue to happen. To find a sub 2, we're going to take whatever this previous term was equal to. Okay, so, we might as well, let's find out what that's equal to. Okay, so when we plug all of this in the calculator, we wind up getting $1,768. So that's how much is in her account, on her first birthday. It collects the interest from the first year, plus they're adding another $750. Now, for her, on the second birthday, right, we're basically going to take what was in her account and, again, multiply that by the interest it'll collect, or it had collected throughout the year, and then they're adding on another $750. And whatever we get, whatever that is, that is. So this process is going to continue. To find the third term, we're going to take whatever this previous answer is, and we're going to multiply it by 1.08, right, because that's what it's growing at, and we're just going to add on $750. And that's just going to keep happening every year. So let's look at the answer choices and see which one says that. All right, so it looks like choice 1 and 2 are following explicit formulas, and it looks like choice 3 and 4 are following recursive formulas. All right, really choice 3 is like popping out at me here, okay? It's saying the initial term is 1,000, and we're taking the previous term and multiplying it by 1.08, and we're adding on 750. This is exactly what our work right here shows. So choice 3 is the answer. With choice 2 and choice 4, because they're adding on 750n, that would mean like n is representing the number of years that have passed. So like on our first birthday, right, if you replace it with a 1, they would be doing 750 times 1. They'd be putting $750 into the account. On her second birthday, right, you'd have to replace the n with a 2. 750 times 2 is 1,500. That would mean they're putting $1,500 into the account. And then, if you multiplied it by 3, you'd be putting in like more and more each year. That's not what's happening. It says they're depositing an additional 750 on each of our birthdays. So choice 2 and choice 4 don't fit what's going on with the 750. Now, if we look at this right here, let's see why this one's not the correct answer. Okay, so this one's a little hard to explain, but I'm going to kind of do my best. This part of it looks good, but this is the part that doesn't match up. This is saying that you're just going to take $1,000 and multiply it by 1.018 times the number of years that have passed. That's not the case, because think about it. On the second year, we're not taking $1,000 and multiplying it by 1.018. We're taking the previous term and multiplying it by 1.018. So this is what's kind of messing us up here. So this is why choice 1 doesn't work out.